going to do some practice problems for chapter 6. First problem will be 6.36 on page 226. So open page 226. Inshallah, today we'll discuss some problems from chapter 6. One of these problems will be 6.36. So let's read 36. It's asked about suppose that the download time is normally distributed with mean, and the mean is given and the standard deviation is given. In this case, the mean equals 0.8 seconds. So again, the mean is 0.8, where sigma equals 0.2 seconds. So mu is 0.8 seconds, that's the time required to download from the internet an image file or something like that. Now he asks about what's the probability that a download time is part A less than 1 second. So what's the probability of getting time less than 1 second? Part B, what's the probability that a download time is between 0.5 and 1.5 seconds? So 0.5 and 1.5 seconds. Part C, above 0.5 seconds. Last time I think we did something like that. So for the first one, b of x smaller than 1, the first step we have to compute the z-score, and that's straightforward. Just z less than 1 minus 0.8 divided by sigma. So 1 minus 0.8 is 0.2. So b of z less than 1. Now by using the normal table, we have the normal table. I think we did many times for this table. Now for 1, so 1 is 0.8413. So it's 0.8413. This is the probability that a download time is smaller than 1. Part B. Now the probability is between two values, 0.5 and 1.5. So in this case, we have to find the z values for the corresponding x, 0.5 and 1.5. So in this case, this one equals 0.5 minus 0.8 divided by sigma smaller than. X is transformed to this score. Smaller than 1.5 minus 0.8 divided by 0.8. Exactly, minus 1.5, smaller than z, smaller than 1.5 minus 0.8 is 0.7, divided by 0.2 is 3.5. So we are looking now for the probability of this score between minus 0.5 and smaller than 0.5. Now, if we are looking for this kind of probability, we have to find the probability of z smaller than 3.5 minus z negative 1.5. Now if we go back to the table we have, now 3.5 all the way down up to the end of this round, the table I have, the maximum value of z is 3.4 all the way up to 9. So that means I have only B of z less than this value. And the corresponding area is 9998. But for this specific example, we are looking for B of z smaller than 3.5, which is roughly equal to 3.49. So the answer is around this value. So it's 9998, approximately 9998. Excuse me? 9998, this value. Minus. This value?
يعني زد حتكون أكبر من minus 1.5.
Z greater than 1 minus 1.
في minus. في minus.
We are looking for minus 1.5 up to 3.5, this area. Now, the dashed area, which is between minus 1.5 all the way up to 3.5, equals the area to the left of 3.5, which is B of z less than 3.5, minus the area to the left of negative 1.5.
The same if we said 1 minus z.
Greater than 1.5. This value, if we are to compute the probability of z smaller than negative 1.5, either you can use the normal table directly, but the other page for negative z scores. In this case, minus 1.5. 0668. Okay. Now imagine that you only have the positive z-score table.
1 minus above 1.5.
Again, suppose that the table you have in the exam is just the positive values of z. How can we find the probability of z greater than minus 1.5 or smaller than minus 1.5? In this case, B of z is less than negative 1.5. The area to the left here is the same as the area to the right of the same value, but positive one. So this is equal B of z greater than 1.5. Because the same area, minus 1.5 all the way up to minus infinity, that equals from 1.5 to infinity because of symmetric distribution. Now, B of z greater than 1.5, the table we have here gives the area to the left of z. So this is 1 minus B of z less than 1.5. Now 1.5 from this table is 9332. Okay, so that will give 0668, which is the same result as we got directly from the negative z table. But make sure that in the exam I will give you just only the positive table. Okay. Now subtract these two values, you will get the answer for this, for part B. 930. 9330. This is the final result for this example. Now, part C. What's the probability that the download time will take above 0.5 seconds? So we are looking again, B of x above 0.5. Similar way as we did in part A. So B of z 0.5 minus the mean, divide by sigma. So B of Z greater than negative 1.5. Now B of Z greater than minus 1.5. It means we are looking for the area above minus 1.5. So this area. Now the area above 1 minus 0.5 equals 1 minus B of Z less than negative 1.5. As we did here, this probability is 0.668. So the answer again is 9332. So that's for part C. Any question? Now, part D. And D ask about 99%. 99% of the download times are above how many seconds? Exactly. In this case, the probability is given, which is 99%. Now, if 99% of the download times are above how many seconds? So in this case, we are looking for the value, for example, for A, such that B of X greater than A equals 99%. Now, in this type of problems, we have to make a graph first in order to determine the location of A. Because A may be to the right or to the left side. It depends actually on two things. Number one, the sign is greater than or smaller than, and the other is the probability. Is it above 0.5 or smaller than 0.5? So you have to keep careful for this type of questions. So in this case, it should be to the left. It should be to the left. Because the area to the left here makes sense. It's 99%. But if the location is to the right side here, it doesn't make any sense that B of X greater than or equal 99%. Because the area here is split into two halves. So 50% to the right, 50% to the left of the vertical line here. So the A should be to the left side. Make sense? Now, B of X greater than or equal 99%. So this area is 99%. Now, if we go back to the table we have, the table again gives the area to the left side. So this one exactly equal B of X smaller than A, which is 1%. Because the area to the right of A is 99. So the area to the left of A is 1 minus 99, which is 1%. Now, here we have to look inside the body of the table at the value of 0.1. So in this case, this score should be negative or positive. Since the probability is 1%, which is smaller than 0.5, so it should be negative. So if you go back to the table, negative 1. Look at 0.1. Minus 2.34. the approximate answer actually is 0099. The closest value. You may take this value. You will be okay. So this one is more closer to 01 than 0102. So my corresponding z-score is negative 2.4. I'm sorry, 2.35. So z-score negative 2.33. 0123. So this is the approximate answer. Sometime maybe if you have a calculator or Excel, you may determine the exact value in this case, which is minus 2.3263. This is the exact answer. But the approximate one is fine. So my z-score is negative 2.33. Now, the value of A equals mu plus z sigma, the one we just discussed last time. If you remember, when z equals minus mu divided by sigma, just a cross multiplication, you will get x minus mu equals z sigma. That means x equal mu plus z sigma. X is the same as A, so A equals mu plus z sigma. Mu is given 0.8, z negative 2.33 times sigma. That will give the final answer, which is 0.3347. So again, he said that 99% of the download times are above how many seconds? So we are looking for the value of A such that P of X greater than or equal 99%. So A is located to the left side of the curve, normal curve. So, and again the table gives the area to the left of Z. So the area to the left is 1%. Now if you check the Z value corresponding to this one, 101, we figure that Z, the approximate answer is negative 2.33. Now just use this value and plug it into this equation, you will get this result. Yes. 0. Z negative. Should be negative. Last part E. %. 95% of the load times are between what two values approximately distributed around the mean. So around 95% of the download times, what two values symmetrically distribute around the mean. So the area here, for example, between A and B is 95%. And he mentioned the symmetry. So this is A, the same as B, but still we have negative sign. So we are looking for the probability of A, of X. Between A and B equal 95%. Now by symmetric distribution, exactly this value A is the same as B, but with negative sign. Now, since the area between A and B is 95%, and we have symmetric distribution, 5% left, divide by 2, that means 2.5 to the left of A and 2.5% to the right of B. Now, what are the values of A and B? Now, if you look at this value, B of x less than A equal 2.5%. Be careful, it's 0.25. Now, what's the value of A such that B of x is smaller than or equal to this one? The same as just we did in part D. So that's A. Now, what's the z-score in this case? If we go back to the normal table, now we are looking for zero to 5. This is the value zero. So minus 1.966. So z equal minus 1.96. Okay. So now my A equal mu plus z sigma. Mu is given is 0.8. Sigma is minus 1.9 times the value of sigma, which is 0.2. Similarly, to get the value of A, B of x is less than B equals, now the area to the left of B, 95% plus 2.5, so that's 97.5. Again, B of x smaller than A is 2.5%. Now, to get the corresponding z value for 0 to 5, we have to look at the normal table inside the normal table here. So 0 to 5 corresponding to z-score of minus 1.96. So my z-score is negative 1.96. Now use this value here. So mu equal 0.8 is the mean, minus 1.96 z-score times sigma. The other part, to get the value of B, the probability of x is smaller than B equals 95 plus 2.5, which is 975. By using the same way, we'll get that z-score is 1.96, as we mentioned before. Because these two values here should be the z-score the same. So now B equals mu plus 1.96 times sigma. And that will give A equal 0.408. And B equal 1.1920. So these are the two values which has 95% between them. So 95% of the data, 95% of the download times are between 0.4 seconds and 1.19 seconds. Makes sense? That is, again, 95% of the download times are between approximately 0.4 seconds and around 1.2. So this value is 0.4. The other one is approximately 1.2. So again, 95% of the download times are between 0.4 seconds approximately and 1.2. This problem maybe is the most important one for this chapter. Exactly in the exam, you will see something like that. Either for part A, B, and C, which are the same, and the backward normal calculations as part D and E. Any question? Let's do some true and false problems for the practice in chapter 6. No, the z-score should be one positive and the other is negative, not A and B. The corresponding z-score here should be have the same values but negative sign, not A and B. Now let's do some practice problems for chapter 6. Now just look at the quantity. The probability that standard normal random variable Z falls between minus 1.5 and 0.81. So it's similar to this one. But this is straightforward, z-score between minus 1.5 up to 0.81. Okay. So number 23 again, the probability that standard normal random variable Z fall between minus 1.5 and 0.81. So in 23 we are looking for this probability. So it's Z less than 1.81 minus. Now just do it by yourself. You will figure that the final answer is 0.74. That's for 23. I think straightforward one. And let's do one more. 25, for example. The probability that standard normal random variable is below 196. Z below 1.96. Now from the table, if we look at the normal table, 1.96. Now the area below 1.696, 975. So it mentioned that it's 0.4. So this one is false. Because the area to the left of 1.96 is not 0.475. It's equal 975. That's for 25. Let's do the odd numbers. The probability that standard normal random variable falls between minus 2 and minus 0.44. I'm sorry, between minus 2 and negative 0.44. So this is the same as Z smaller than negative 0.44 minus Z less than minus 2. It says the answer is 0.6472. The exact answer is 0.3072. So the one there is incorrect. So that one is incorrect. 27 is incorrect. You may figure this one by using the table, or sometimes by Excel you can do this problem. Let's do different one. Look at 29, the odd number, 29. 29 says that a worker earned $15 per hour at a plant and is told that only 2.5% of all workers make a higher wage. If the wage is assumed to be normally distributed, and the standard deviation of wage rates is 5 per hour. So the standard deviation is 5 per hour, $5 per hour. The average wage for the plant is 7.5. Now again, go back to the problem. It says that a worker earns $15 per hour and is told that only 2.5% of all workers make a higher wage. So it's X more than
1.5
$15 equal 2.5%. That means 0 to 5. So let's see if this one is true or false. So again, this man earns $15 per hour at a plant, and he's told that only 2.5% of all workers make higher wage. Means greater than the one he just got, which is $15. So B of X greater than 15, the claim is 2.5%. So let's see if that percentage is true or false. So in this case, we have to convert to this score. So it becomes B of Z greater than 15 minus the mean divided by sigma. So B of Z greater than 7.5 divided by 5 is 1.5. Makes sense? 1.5. So now B of Z greater than 1.5. 1 minus B of Z is less than 1.5. Go back to the table. 1.5 is, look at the table, 9332. 9332. So the answer should be 668. That means 6.68% of the workers have higher wage, not 2.2, not 2.5%. So that means this is incorrect. So that's false. So the answer is false for this problem. Look at 31. Do you have any question for this one? For 29? In 29, the claim is 2.5% of all workers have higher wage than $15. Let's see if this claim is true or false. So the problem again is B of probability of X greater than 15 equals 2.5%. We figure out that the answer is 6.68%, so the claim is false. Now 31. Any set of normality, any set of normally distributed data can be transformed to its standardized form. True or false? 31. It says that any set of normally distributed can be transformed. That's true. Let's see 32. The middle spread That is the middle 50% of the normal distribution is equal to one standard deviation.
خطأ.
That's true. It's incorrect. Because we mentioned that 68% of the data are within one standard deviation above the mean. Within the mean. So it's false. Instead of 50, we have to say that 60-80%. The empirical rule. 33. Normal probability plot, the one we just discussed last time, may be used to assess the assumption of normality for a particular batch of data. As we mentioned before, one of the rules that we can use to determine if the data is normally distributed or not is called the normal probability plot. So it's true. So again, normal probability plot is used to assess the assumption of normality for a data. Let's see, for example, 35. The probability that a standard normal variable z is positive is the probability that a standard normal variable z is positive is, now if you, it's the z table, z curve.
More than 1.5.
Is what?
More than greater.
Again, the probability, the probability that a standardized normal variable z is positive is the probability.
50%.
Let's do one more. You know, these problems are the same. Some of these. So let's skip. Now, look at 67. Suppose Z has a standard normal distribution with a mean of 0 and standard deviation of 1. And the probability Z is less than 1.15. Straightforward, just go back to the table. Z less than 1.15, 1.15. 8749. So that's correct. 8749 is correct. Any question? So let's move chapter 7. So that's for the practice for chapter 7. Chapter 7 talks about actually two things. One is called sampling, and the other topic is sampling distribution. Mainly, there are 4 learning objectives for this chapter. Number 1, we have to distinguish between different sampling techniques or methods. We'll talk about probability and non-probability sampling, and we have to distinguish between these two. The other objective for this chapter will be the concept of sampling distribution. Now, instead of using just x, as we did in chapter 3, what's the probability of x, for example, less than 15. Instead of that, we'll talk about not x, the statistic itself, maybe x bar or the sample mean. Number 3, to compute probabilities related to the sample mean, not the exact value of x. So here we are looking for v of x bar smaller than 1.5. So in this case, to compute these probabilities, we have to know that all the concepts in chapter 3 should be understood. Otherwise, you cannot do any problems here. Because here will depend actually how can we find the probabilities underneath the normal table. But instead of x, in this case we have the sample mean x bar. So that's the difference between chapter 6 and the next chapter. So here in chapter 6 we are talking about the sampling distribution of the sample mean. Also there is something new which is called sample proportion. Now let's see the difference between these two. If you remember at the first class we said there are two types of data. One is called numerical, which is quantitative, and the other one is qualitative. So we have numerical data, which means quantitative data, and qualitative data. Now, for numerical data, we can use the sample mean as a measure of central tendency, x bar. But for qualitative data, for example, if we have gender either males or females, in this case we cannot say that the mean of females in this school is 1.2, for example. It doesn't make any sense. But it's better to say that IUG has, for example, 70% females. Makes sense. So this one is called percentage or proportion. So here we will talk about the sample proportion. So sample mean is used for numerical data, but on the other hand, the sample proportion is used for qualitative data. In this chapter, we are going to know how can we compute the probabilities related either to the sample mean or to the sample proportion. The last objective for this chapter will be the importance of using something called central limit theorem. Under specific conditions, we'll know how to use this theorem. So these are the mainly four objectives for this chapter. So you have to make sure that you understand 100% how to compute all types of probabilities under the normal curve, either straightforward calculations or backward calculations, I mean inverse calculation. If the probability is given, how can we find the corresponding x value? Or how can we find the value by itself, the value of the probability by itself? So next time, inshallah, on Sunday, we are going to start chapter 7, why sample? Why most of the time in our researches we are using the sample instead of using the population. Any questions? So that's all.